In this video, we will discuss about finite state methods. Generally, in digital circuits, you will come across mainly two types of circuits, mainly combinational and sequential circuits. To design from a combinational circuit, you can get a truth table. If you have truth table, you can design a combinational circuit, vice versa. And similarly, a sequential circuit can be defined with a state diagram. If you have state diagram, you can also design a sequential circuit. State tables is nothing but you can obtain state tables from state diagram. So, state diagrams you can draw in two ways. One is Mealy, other is Moore. This can be drawn for only sequential circuits. Now, we will briefly understand about difference between Mealy and Moore sequential circuits. Here, in Mealy sequential circuits, the outputs are function of present state as well as the inputs. But in Moore sequential circuits, the output is function of only present state. It doesn't depend on inputs. This is the logic diagram for a Mealy sequential circuit. You will be having inputs. Output is taken here. This is output is taken here. You will be having one combination logic. As this is a sequential circuit, compulsory you will be having memory. This is next state, and this next state is stored in memory, and this will act as a present state for the next clock cycle. Similarly, for combination logic, this is input and this is output. See, here output depends on only next state. This is next state. This is next state. This becomes present state. Here output depends only on present state. In Mealy sequential circuits, here you will be having less number of flip-flops. So, it is because you will be having less number of states here. That means in state diagram, the number of states are less in Mealy sequential circuit compared to Moore sequential circuit. Here in Moore sequential circuits, the number of state diagrams are more. So we require more flip-flops. From here you can observe one point, that is number of states is directly proportional to number of flip-flops. If there are more number of states, you need more number of flip-flops. So you are using more number of flip-flops here. Here the design may be complex compared to Mealy. Then you may be getting a doubt that then why we should choose, why we are studying about Moore sequential circuit, as it is taking more number of flip-flops and the circuit design is also complex. The reason is that here it is very safe to use. Here it is not safe to use. Here it is not safe. These are less safer mainly. It is more safer, that's all. We will go for more sequential circuits depending upon the application. Yeah, in this video we will discuss exclusively on Mealy sequential circuits and how to draw state diagram on Mealy sequential circuit. For drawing a state diagram, mainly you need to remember 3 points. In Mealy circuit, for drawing a state diagram, you need to remember 3 points. First one, number of states. It can be calculated with the formula 2 power n. 2 power n, where n is number of flip-flops in the given sequential circuit. First, you should find the number of states. Second, you should find number of branches. Coming from each state. It is also 2 power x, where x is number of direct inputs. Third one, you have to find a relationship between q of t plus 1, that is next state, versus direct inputs. You have to find the relationship between this. Okay. Now let us take an example. Let us design state diagram T flip flop using Mealy state diagram using Mealy state. We know that T flip flop, this is input. Let us assume this is it, which is input. Assume it as a positive edge clock trigger. This is output. This is the sequential circuit. This is the circuit. As this is flip flop, so we can this is a sequential circuit. Now here, number of states can be found with number of flip flops. Number of states. Number of flip flops, we have one flip flop, 2 power 1, so 2 states. Let us assume both states are q is equal to 0 and q is equal to 1. Next, number of branches from each state. Here, how many direct inputs are there? Direct input is nothing but the input which can be controlled externally. Here, only one input is there which can be controlled externally, that is x. So, the number of branches from each state is nothing but 2 branches. Let us assume they are x is equal to 0 and x is equal to 1. 2 branches from each. Next, we have to find the relationship between q of t plus 1 versus t. T is nothing but here input. We know that from the characteristic equation of t flip flop, what is q of t plus 1? Nothing but t XOR with q of t. This is the characteristic equation. Always try to remember the characteristic equation of all the 4 flip flops: SR flip flop, JK flip flop, T flip flop, and D flip flop. Now, if t is equal to 0, then what will be q of t plus 1? 0 XOR anything. It's anything. Like 0 XOR A is A or 0 XOR B is B. It will be same. It acts as a buffer. So 0 XOR q of t is q of t. Second, if t is equals to 1, what is q of t plus 1? When one input of an XOR gate is 1, then it acts as an inverter. Remember this point. Q of t. It acts as an inverter for the given for other input. You have two inputs, 1 and q of t. It acts as an inverter of q of t, that is q bar of t. Now, let us draw the state diagram. We have two states. Already we have defined, one is q is equal to 0 and q is equal to 1. Q is equal to 0. So, q is equal to 1. Now, let us assume we are in the state q is equal to 0. So, when t is equal to 0, what is q of t plus 1? It is q of t. It is same state. When t is equal to 0, it is q of t. We are in the same state. Next state is the same state. Now, when t is equal to 1, it is complementing. Q of t plus 1 is q bar of t. 0 complement is 1. So, when t is equal to 1, it goes to the state. Now, let us assume we are in the state q is equal to 1. When t is equal to 0, output is q of t itself. When t is equal to 1, output will get complement. Simple. This is the state diagram. I think it looks very simple, right? Okay. Let's go for another example. Draw the state diagram. State diagram of the given sequential circuit. Note that we are using only Mealy sequential circuits. We are drawing for only with the help of Mealy, not Mealy. Use the SQ bar, I1, I1. Select line. This is in X. Clock sensor. This is the divergence. For this sequential circuit, we have to draw the state diagram. Yeah. How many flip flops are there? This is flip flop. This is mux. 2:1 mux. This is D flip flop. How many flip flops are there? Just count only the number of flip flops. One flip flop. So number of states is equals to 2 power 1. 2 states. Let us assume both states are U is equal to 0, U is equal to 1. Direct inputs. One direct input. What is the direct input here? X. X is the only direct input here. Don't consider clock as an input. Clock is used only for triggering this flip flop. Only we have one controlled input, one controlled external input, that is X. So number of branches will be 2 power 1. 2 branches from each state. 2 branches from each state. Now third step, we have to find the relationship between Q of t plus 1 next state versus direct input X. I think first you have to write the characteristic equation of D flip flop. What is the characteristic equation of D flip flop? Q of t plus 1 is equal to D. The characteristic equation of D flip flop. Now, what is D? D is nothing but F. What is F? F is the output of the mux. We know that for 2/1 mux, output F can be written as F can be written as, what is here? X bar I naught plus X in I1. I have to understand this equation. What is here? X bar. X bar is not, X bar is direct input. What is I0 and I1? I0 is nothing but Q bar, I1 is nothing but Q. So let X bar into Q bar plus X into Q. This is F. What is F? F is D. This is D. But what is D? D is nothing but Q of t plus 1. We got a relationship between next state in the terms of present state. Present input. Present direct input. It is Q bar of X bar of t plus X into Q of t. Now, when X is equal to 0, what is Q of t plus 1? If it is 0, this whole term becomes 0. 0 complement is 1. 1 into Q bar of t is Q bar of t. when x is equals to when what is q of t plus 1. When it x is equals to 1, it becomes 0. 1 into q of t is nothing but q of t. Now let's draw the state diagram. We know that there are two states, x is equals to 0, q is equals to 0 and q is equals to 1. Now let us assume we are in the state q is equals to 0. What is q is equals to 0? When what happens when x is equals to 0? X is equals to 0, output the next state is its complement. Complement of 0 is nothing but 1. So when x is equals to 0, output goes to 1. When x is equals to 1, it remains in state. Q of t plus 1 is q of t, it remains in same state. When x is equals to 1. Similarly, when x is equals to 0, it gets complement. When x is equals to 1, it remains in same state. I hope you understood this example. Let's take somewhat complicated example. Draw the state diagram of the following sequential circuit. Standard. Draw the state diagram of the following sequential circuit. We'll draw the sequential. It is also almost similar to the previous one, but slightly I am modifying it. This is 2:1 max. This is AND gate. This is AND gate. We have to draw the state diagram. Here you can see from the diagram how many flip-flops are there? One flip-flop. Similar to previous problem, two states. This q is equal to 0, q is equal to 1. And we have one direct input, which is x. So, two branches and which is statements. A is equal to 0, A is equal to 1. Now we have to find the relationship between next state q of t plus 1 versus input. First write the expression for f. F is x bar f is x bar to I naught. I think we need this is I naught. This is I naught. Okay. Yes, problem. I1 I naught. Yeah. This I1, this is I naught. I1 I naught. This is I1. X bar into I1. Yes. x into I1, x bar into I0, x into I1. This is the equation. So what is I0? I0 is nothing but q bar, I1 is nothing but x bar into q bar of t plus x into q of t. I1 is q of t, right? Yeah. Now we know that characteristic equation of t flip-flop. What is the characteristic equation of t flip-flop? Q of t plus 1 is nothing but t XOR with q of t. Characteristic equation of t flip-flop. So problem also has solution. So what do you do? Now what is t? T is nothing but AND operation of q of t and f. I think this color is not visible. T is nothing but AND operation of q of t and f. What is f? Q of t into what is f? X bar into q bar of t plus x into q of t. Q of t into q bar of t results in 0. Q of t into q of t is q of t. So you will get x into q of t. X into q of t. This is t. Now what is q of t plus 1? T XOR with q of t. What is t? X into q of t. XOR with q of t. Take q of t common. X XOR with 1. This 1 XOR with anything is its complement. X bar into q of t. This is q of t plus 1. Finally, you got a relationship of q of t plus 1 in terms of input, direct input, that is x. Now, if, now let us draw the state diagram. If x is equal to 0, x is equal to 0. If it is 0, 0's complement is 1, then q of t plus 1 is q of t. If similar to if x is equal to 1, q of t plus 1 is 1 complement is 0, 0 into anything is 0. Okay. Now we will draw the state diagram. Q is equal to 0, q is equal to 1. Now let us assume that we are in a state q is equal to 0. What happens when x is equal to 0? When x is equal to 0, the output is, next state is the present state itself. Q of t plus 1 is q of t. X is equal to 0. It is the same state. When x is equal to 1, it is in the state 0. So for x is equal to 1 also it is in the state 0. Suppose we are in q is equal to 1 state. When x is equal to 0, it is in the same state. When x is equal to 0, it is in the same. When x is equal to 1, it goes to the 0 state. This is a state diagram. I hope you understood this. Now here for sequential circuit we have drawn the Mealy state diagrams. Now we will learn how to draw state diagrams for sequence detectors. Before that, we have to know what is a sequence detector. Generally, when there is a random sequence, suppose there is a random sequence like 1 0 0 0 1 0 0 1 0 0 1 0 1 1. This is a random sequence, it goes on. You have to detect the sequence like 101. How many times this 101 is present in this sequence? At that point, you have to note down. You have to take down output as 1. In all other cases, you have to take output as 0. See, this sequence detection is very important because in image processing, pattern recognition is found with this sequence detector itself. In order to detect a pattern, you have to use this sequence detector. So, sequence detector are mainly two types. One is overlapping sequence detector, another is non-overlapping sequence detector. Coming to non-overlapping sequence detector, once the required sequence is detected, then forget those bits and start detecting from next bit. Coming to overlapping sequence detector, here you can use some of the bits of the detected sequence to detect another new sequence again. I will explain you clearly with the help of an example. See, this is the sequence 1001 00011 00001 something. I have taken a random sequence. I have to detect 10001. I have to detect this sequence. When this sequence is formed, take down output as 1. How many bits are there? 1, 2, 3, 4, 5 bits are there. So minimum you need 5 bits to detect a sequence. So first the 4 bits output will become 0 because you need 5 bits. Whether it may be a required required sequence or not required sequence, we need at least 5 bits. So first 4 bits output will be 0. Okay, let us consider non-overlapping case. First 4 bits output will be 0. Consider the next bit 1. 10001. It is the required sequence. So output becomes 1. We have detected one sequence. Now what you have to do in non-overlapping is forget up to these bits. You forget these bits. Now start fresh. First 4 bits output will be 0 because you need minimum 5 bits to, as there are bits are, as we have 5 bits, you need minimum 5 bits. Next it is 1. So output is 0. Now you forget first bit and you go with 00110. It is not matching, output is 0. You forget another bit 01100. It is not matching, forget 0 again. 11000. It is not matching, output is 0. Now you forget 1. Now 10001. 10001. This is 1. 1. 1 not 0. Yeah. Here we found a sequence. Here the output should be 1. Now forget this bit. Now don't now already you have found the sequence, so forget all these bits. If the sequence goes on, now again start from here. So here you can observe no overlapping in the detected sequence. This is one sequence is detected, here another sequence is detected. These two doesn't overlap. The number of times output becomes 1 is 2. That is non-overlap sequence detection. Coming to overlapping sequence detection, let's take the same example. Let's take the same example. 0 1. Let's take the same example. Now for overlapping or for non-overlapping, minimum you need 5 bits to detect the given sequence, as we have the given sequence of 5 bits. So first 4 bits output is 0 1 2 3 4. Next fifth bit is 1, so output is 1. In case of non-overlapping, what we have done after the sequence is detected, we forgot all those bits and we started with next bit. We started matching with next bit. But in case of overlapping, till here we got output as 1. Now what you have to do is just now again here you should forget first bit, and from the detected sequence itself you take the remaining 4 bits and the new bit. It is 0 0 0 1 0. It is not matching. Output is 0. Again you cancel the first bit and you take remaining. So it is 0 0 1 0 0. Output is 0. Again you cancel this bit and you take remaining 0 1 0 0 0. Output is 0. No. Again you take 1 0 0 0 1. Initially we got this as a detected sequence. Now 1 0 0 1 0 0 0 1. Again here the sequence is detected. What it is 1 0 0 0. Now again you remove this one and you count from here 0 0 0 1 1. It is 0. You remove one bit 0 0 1 1 0. It is 0. Again remove one bit 0 1 1 0 0. You remove 0 1 1 0 0 0 0. Now you remove 1 1 0 0 0 1. It is detected. Now you remove 1 0 0 0 1 1. Sequence goes on. Also detection goes on. Now here you can see that in non-overlapping case we found 2 sequences are detected, but in overlapping case we found 3. The reason is that here you can see this one is common to first sequence as well as second sequence. Here one is overlapping with 2 sequences. So that is why we are calling this as overlapping sequence detector. Now in the next video we will see how a sequential circuit is designed for this sequence detector. In order to design a sequential circuit, we need a state diagram. So in the next class I will design a state diagram for this sequence detector in Mealy form, in Mealy sequential circuit, and with the help of that state diagram we can design a sequential circuit to detect this sequence. Yeah, thank you.